Hello students, I am Mrs. Rima Shah Vora from Deccan Education Society, Brihan Maharashtra College of Commerce, Pune. I teach mathematics and statistics, and today we are going to see chapter number 7, assignment problem and sequencing from maths paper part 2. In the first session we have already covered assignment problem. So in this session we are going to see what do you mean by sequencing. So sequencing basically means ordering. So we arrange certain things in an order and then the processing starts. So for example, if you want to make a shirt, so what does the industry do basically? First the raw material, that is the cloth, will be required. Then the cloth will go for dyeing, printing, pressing, and then it will go for stitching. So these are the procedure which every company will follow to get the final product. So now let's see how do we use it in mathematics. We'll go through the PowerPoint presentation now. So students, any production requires organized utilization of natural resources, labor, and finance. Sequencing is a process of selecting a path which each part of the product will follow before turning into finished product from the raw materials. Example, if a publisher wishes to publish 10 different books, then each book has to go through composing, printing, binding, and finishing. Here the problem of the publisher is to decide which book is to be processed first, which is to be processed next, and so on. He has to determine an order, that is a sequence of giving the manuscripts to the press in such a way that the total elapsed time and the total idle time for the machines is minimized. This is an example of 10 jobs and 4 machines sequencing problem. 10 jobs as in because there are 10 books and there are 10 job 4 machine problem, and the elapsed time means the time from the start of the first book till the completion of the last book is processed. So students, the sequencing problem is to determine the sequence, that is the order of a series of jobs to be done on a finite number of service facilities in some pre-assigned order so as to optimize the total time involved. So by this example you have understood what is the sequencing. The general sequencing problem, it is defined as if in an industry there are n jobs to be performed one at a time at each of m different machines, then the sequencing problem is to determine time from the start of the first job up to the completion of the last job, where we are given the order in which these machines are to be used for processing and also expected processing time taken by each job on the machines. So we will already be given the order in which these machines are to be used and the processing time. Both will be given to us. Now let us see some notations and assumptions which we will be using throughout the chapter. First, the notations. The following notations are used. MIJ, that is processing time required by the ith job on the jth machine. So like how we used to do in matrices, the same thing we'll be following. For ith job and jth machine, MIJ will be written, where I will go from 1 to up to n and j will go from 1 to up to m, depending on the number of jobs and number of machines. Secondly, T is equal to total elapsed time, that is the included idle time if any for processing all the jobs. Idle time predefine the order and then only we can do the job. For example, before composing a book you cannot send it for printing, and after printing only it can go for binding. So now from this day-to-day life example you have understood what does it mean. So let us see the processing of n jobs through 2 machines. Optimal sequence algorithm out here is find minimum of AIBI. If there are 2 machines, you will find out the minimum. Then step 2 is if the minimum processing time is AR, then process rth job first. So, and if the minimum processing time is BS, then process sth job in the last. So by this you just understand that if there are 2 machines, first is machine A, machine B, but if the minimum is on machine A, then you will start writing from the left hand side. But if it is minimum on machine B, that is the second machine, so then you will start writing from the right hand side. From the last you will start writing. So just remember that. Then step 3 is in case there is a tie, break it arbitrarily. That is you have to just break the tie randomly. That you will, all these things you will understand while we are doing the problem. Okay. And lastly, cross off the jobs already placed in the sequence and repeat steps 1, 2, 3 until all the jobs are placed in the sequence. Once all the jobs are placed, then you will prepare the working table and find total elapsed time. So for all these things, all the steps to be followed, now we will move on to the problems. Let us see question number 1. A machine operator has to perform two operations, turning and threading, on 6 different jobs. The time required to perform these operations in minutes for each job is known. Determine the order in which the job should be processed in order to minimize the total time required to complete all the jobs. Also find the total processing time and idle times for turning and threading operations. These are the jobs given to you. As you can see, there are 6 jobs and the times for turning and threading are given. So in the solution now we are just going to write the table again. So jobs are 1, 2, 3, 4, 5, 6. For turning, these are the times in minutes, and for threading, these are the times in minutes. Now, as you can see, the minimum over here is 2 and minimum over here is 1. So out of 2 and 1, the minimum is 1. So you will correspond, now it is corresponding to threading. It is a second machine. So you will write this job 6 from the last, like in this way. So 6 goes last. Now again we are going to compare. So the second minimum was 2, which we saw it was for turning. Okay. So now when we are doing it for the second time, 6 job will be cancelled. You will see minimum only for 1, 2, 3, 4, 5. Okay. Minimum is 2, which is for job 4, and it is for turning. So turning is the first machine. So you will start writing from the left hand side. So 4 will come in the first place. Now next is the problem now reduces to 4 jobs only. 4 and 6 are cancelled. So 1, 2, 3 and 5. Now out of these, 3 is the minimum, which corresponds to both turning and threading. Now this is a tie. So when you are writing, you can just write, therefore job 1 is operated first next to job 4 and 5 is operated at last next to job 6. So you can write it in this way. 1 and 5 both are written because both are minimum. So 1 and 5 are also cancelled. Now only 2 and 3 remain. So minimum from 2 and 3 is 5, which corresponds to turning. Therefore job 3 is operated next to job 1. You will write from the left hand side again as discussed earlier. So 3 will come and lastly you will just put 2 over there. So now remaining job 2 is operated next to job 3. Thus the optimal sequence of job is obtained as follows. 4, 1, 3, 2, 5 and 6. Students, the last sequence which we have obtained, that is expected for you all to write. No need to show all these working. It is okay if you just write down the final sequence. Now we will go for the working table. The minimum elapsed time can be computed as follows. So you have to make like this table: job sequence for turning, time in, time out; for threading, time in, time out; and idle time for threading. Okay. So now these were the sequence which we had got: 4, 1, 3, 2, 5, 6. Now for turning, it had gone in 0 time. Obviously, till it doesn't go, we count it as 0. But for in job 4, it had 2. So it took 2 minutes to complete the job. Therefore, it went in 0 minutes and came out after 2 minutes. Then till 2 minutes, this was empty. This was idle rather, threading. So in 2 minutes, we will write this. And 2 plus 6 will give you 8. Therefore, time out of it is 8. And so idle time for threading was 2. Next, we'll go for job 1 now. So after this is done, it will go in job 1. Okay. So again, you will write that 2. Now go in the original problem that was given. 2 plus 3 will give you 5. After that, it will go in for threading. So it will be 8. Now you will compare things out here, 5 and 8. So the maximum you will write over here, and then add 8 plus 8 is 16. So idle time over here was 0. In 8, again it went to 8. So there was no idle time for threading. So it is 0. Now for job 3, 5 will come. After 5, here it will go in 5 minutes. Then 5 plus 5, 10. Then here it will be 16. Again compare this and then write the maximum. Okay. 16 plus 9, 25. And then again here idle time was 0. This you should compare these two and write the idle time over here. Next is 10. Then 22. Keep on adding from the given question. Okay. So again write 25 over here. 25 plus 10, 35. Idle time is again 0. Next is 22. Then 22 plus 9 you get 31. 35 you will get over here. So compare this 31, 35 is 35. Next is 35 plus 3, 38. Again there is no idle time over here. So 0. Next it will be 31. After this is done it will go here. So 31. Then you will get 42. Here again 42. Now see students, here for turning it has taken 42 minutes. But the last job which was completing for threading, it was 38. So as you can see, 42 is larger than 38. So that's why 42 we have written over here. And now 42 plus 1 is 43. So the last job, that is the 6th job, came out in 43 minutes. Fine. So here the idle time for threading is 42 minus 38, which is 4. So that's why 4 is written here. And then here there is no 0. So idle time for threading is, counted all these things, and it is 6. So idle time for threading we have got. Now we will see idle time for turning. Here you can see that it has finished in 42 minutes. So let us see. From the above table, the minimum total elapsed time is 43 minutes. So idle time for turning is T minus sum of processing time of all 6 jobs on turning. So which is 43 minus 42 equal to 1 minute. Idle time for threading is 6 minutes. Idle time for turning is 1 minute. And this way your problem is solved. Next question. A company has 3 jobs in hand. Each of these must be processed through 2 departments in order AB, where department A press, shop, and department B is finishing. The table below gives the number of days required by each job in each department. So jobs are given, 3 jobs are given. Department A, working days in days it's given, and department B in days. For the sequence in which the 3 jobs should be processed so as to take minimum time to finish all 3 jobs. Also find idle time for both the departments. So again, first of all, we have to find the minimum. So this was the table given to you. You can just write it, or you can write it in the same manner as given in the question. Now as you can see, the minimum over here is 5 and minimum over here is 3. So minimum is 3 from the total, both the departments. So obviously it is in job 2, but it is in department B. So you will start writing from the right hand side. So this way you will get 2 over here. Next minimum was 4, because now 2 is gone. So you will see from 1 and 3 only, which corresponds to department B again. Start writing from the right hand side, and the optimal sequence of job obtained is as follows. So you will write 3 in the middle, and then only 1 is remaining. So write 1. The optimal sequence is 1, 3, 2. So now we go for the working table. Minimum elapsed time can be computed as follows. So as discussed earlier, you have to make like this table: job sequence, department A, department B, idle time for B, and write down the time in, time out. So then 1, 3, 2, write down the sequence which you have got, and the sequence may vary depending on the tie. Okay, so it will go in 0 minutes or 0 days over here, and it will come out in 8 days, because the first variable was 8. Then it will, after 8 days, then only it can go to department B. So that's why this is idle time for department B, and then 8 plus 8 is 16. So here idle time for B was 8. Next, now it will go on job 3 after 8 days. So now 8 plus 5 will get 13, and then we'll go for next. So as I told you earlier, 13 and 16 just compare. 16 is the highest. So 16 you will write, and 16 plus 4 is 20. So there is no idle time for department B, it is 0. Next will be 13, and then 13 plus 6, 19. Now again, here 19 and 20, 20 is the biggest. So write 20, and then 20 plus 3 is 23. So idle time again here is 0. So idle time for department B is 8 days only. Now we will calculate the idle time for A also. So minimum total elapsed time to finish all jobs is 23 days, as you can see over here. Okay, and the idle time for department A is T minus sum of processing time to finish all jobs in A. So it is 23 minus 19 equal to 4 days. And idle time for department B is 8 days. So writing all this is very important, because it carries a mark for each and every step that you write. Next question. Find the sequence that minimizes the total elapsed time to complete the following jobs in the order AB. Find the total elapsed time and idle time for both the machines. So jobs are given. As you can see, there are 7 jobs. Machine A, machine B, the processing times are given. And the solution, as you can see now, minimum out here is in job number 6, which is 5. And it is in machine B. So we start writing from the right hand side. Next is 7, also it has 5, so write 7 also in the first, because it is from machine A. So machine A you will start writing from left hand side, machine B start writing from the right hand side. Okay, now we will again go for minimum. So minimum next, as you can see, it is for 1, it is 7, and it is now here you will not see. Okay, next minimum is, now 1 is gone, 6 and 7 are also gone. Now 2, 3, 4, 5 only. So minimum, as you can see over there, is 10, which is for job 4. It goes for machine A as well as machine B. So you can choose any arbitrarily and you can write over here. Then 7, 1, 4. Okay, now minimum is, now you have to check only from 2, 3 and 5. So as you can see, the minimum is 14, which corresponds to 2, 3, 5, all 3. So you can just write 5, which goes for machine A. Then next is, again, minimum is 2 and 3 remains. So both 2 and 3 are for machine B. So you will start writing from the right hand side. And hence the optimal sequence is obtained as 7, 1, 4, 5, 3, 2, 6. Now we will prepare the working table. So total elapsed time is obtained as follows. You will get the job sequence which we obtained right now. You can obtain a different sequence also, but just consider one while making a elapsed time table. Okay. So it will go in 0 minutes, come out in 5 minutes. Then it will go in 5 and then come out after 12. So idle time for machine B is 5. Similarly, we will keep on doing 5 and then 5 plus 7 gives you 12. Then compare these two. So they are same. You just write 12. 12 plus 12 gives you 24. So idle time is 0. 12 minus 12 you should do and just write down the answer over here. Then it will go in 12 minutes, come out after 22. Again go in 24 and then 34. So again idle time is 0 as you can see. Next is 5. So in 5 you will see 22. Then plus whatever number is there, add it up. So here you get 36. Again you will get, compare these to 34, 36. Here it is larger is 36. So write 36 over here and then 52. 36 minus 34 is 2. Therefore the idle time for machine B over here is 2. Next is 36, then 55. Again 55 and 52 comparing, we write 55 over here and it comes out in 69. So the idle time is 3. Next is 55. It comes out in 71. It goes in machine B at 71 minutes and comes out at 85 minutes. So idle time for machine B is again 2 minutes. Then 71, 86, 86 and 91. As you can see 86 and 85. So you will write 86 over here and then again idle time is 1. Add this up. So you get idle time for machine B is 13. Okay. Now we will calculate the idle times. So optimal sequence over here was 7, 1, 4, 5, 3, 2, 6. Total elapsed time is 91 units. So idle time for machine B is 13 units. And idle time for machine A is T minus processing time for T, which is 91 minus 86 is 5 units. So here as it, like minutes or days or hours was not given. So you will just write it as units. Okay. Next question is, a book binder has one printing press, one binding machine and the manuscripts of a number of books. The time required to perform the printing and binding operations for each book are shown below. Determine the order in which books should be processed in order to minimize the total time required to turn all the books. Also find idle time for both the machines. So there are 6 jobs given to you on machine A and machine B, both. So here the solution is, find out the minimum again. Minimum is on job 6, which is 10 and it is for machine B. So you will write on the right hand side. Next is the minimum, as you can see over here, minimum is 20 on job 4, but it is on machine A. So you will write on the left hand side. And then 4, 6 are there. Now 4 and 6 are gone. So don't look at them. Now you will go for 1, 2, 3 and 5 only. As you can see, the minimum is 30 over here also and here also. So just write 1 and 5. Now 2, 3 are remaining. So minimum, as you can see, it is 50. So 50 is for machine A. So it will come next to 1 over here. Write there 3 and lastly 2. So 4, 1, 3, 2, 5, 6 is the optimal sequence. So minimum elapsed time can be computed as follows. This is the sequence which we obtained, 4, 1, 3, 2, 5, 6. It will, in machine A, it will go in 0 minutes, come out in 20. Then it will go in 20 and come out in 80. So idle time for machine B is 20 hours. Then it will, for job 1, it will go in 20 hours, come out after 50 because 20 plus 30 will give you 50. Now again 50 and 80. So 80 you will write over here. Then time out is 80 plus 80, 160 and idle time for B is 0 hours. Again it will go out for third job in 50 hours. After that 50 plus 50 it will come out in 100 hours. Okay. And later on it will go in machine B after 160 hours. So 100 and 160 compare, 160 is the highest. So write 160 and then add it up, you get 250. okay, and 0, because here 160 minus 160 is 0 hours. Similarly, you will write for job 2 also, 100, 220, 250, 350 and 0 is the idle time. Then 220, 310, 350, 380 and 40. Here as you can see, from 310 it has got 340. So that's why we have got 40 hours as idle. From 420 minus 380 you get 40 hours. So idle time for machine B is 60 hours. Now we will calculate for machine B as well as A. So minimum total elapsed time is 430 hours. Whatever the total you get in from the table, idle time for printing machine A is T minus sum of processing time of all 6 jobs on machine A, and it is 430 minus 20, which is 10 hours. And already we have obtained from the table, idle time for machine B is 60 hours, idle time for machine A is 10 hours. So the problem is done. Now students, we also have processing jobs through 3 machines. So let us see the algorithm for that. Optimal sequence algorithm is as follows. Let there be n jobs, each of which has to be processed through 3 machines, say A, B and C in the order A, B, C. Then we use the following steps to solve the problem. First, reduce the 3 machine problem to 2 machine problem. For doing this, at least one of the following conditions must hold true. So minimum of AI, find the minimum from machine A, find the maximum from machine B. If this is greater equal, if minimum of AI is greater equal max B, and secondly, if minimum of CI is greater equal max of BI. If any one of these conditions satisfy, then we will go for the next step. If it doesn't satisfy, then the problem cannot be solved. So if any one of the conditions satisfies, then we introduce the 2 fictitious machines, that is G and H. And what is G? G is equal to AI plus BI. So we will add corresponding columns of AI, BI to get machine G. We will add corresponding columns of BI and CI to get machine H. So it will be converted to 2 machine problem. Once the optimal sequence is determined, go back to the original 3 machines and prepare the working table for 3 machines. So we will just prepare the sequence over here by considering the 2 machines. So now 3 machines is converted to 2 machines, and then for working table you have to consider the original table which is given in the question. Okay, so let us see the example now. A publisher produces 5 books on mathematics. The books have to go through composing, printing and binding done by 3 machines P, Q and R. The time schedule for the entire task in proper unit is as follows. Books are given A, B, C, D, E, machine P, machine Q, machine R. The times are given, okay. Determine the optimum time required to finish the entire task. So let us see the solution. This is the table which is given to you originally. Okay, now let us find the minimum of P. Minimum of P, as you can see, is 4. Maximum of Q is 6 and minimum of R again is 6. So let us see the condition. Minimum R is greater equal maximum Q is satisfied. So the problem can be converted into a 5 job 2 machine problem, and 2 fictitious machines are G equal to P plus Q and H equal to Q plus R. So students, we are just going to find out G by adding P plus Q, these 2, and H will be Q plus R. So for example, G, the first element will be 9, and for H the first element will be 13. Then again for B it will be 15 and here 16. So let us see the new table which we got. A, B, C, D, E, the jobs, we have still not given the sequence order. So 9, 15, 10, 9, 9, and H will be 13, 16, 8, 10 and 15. Now it is converted to 2 machines. So by using the 2 machine, find out the optimum sequence. Here the minimum you can see is 8, which is for machine H. So start writing from the right hand side. You will get C over here because it corresponds to C. Then minimum is, as you can see, 9, 9 and 9. So let us write the next. The problem now reduces to only 4 jobs, which is A, B, D and E. And you can see that there are 9 only. So let us write the sequence. Therefore, either of the jobs A, D or E is processed first of all the remaining next to job A. You can write it in any form. So maybe you get a different sequence. Okay. So it will be A, D, E, and lastly you will get, you can write A, E, D also. You can get D, A, E also, E, A, D, D, E, A, E, D, A and so on. So the remaining job B is processed next to job E. Thus the optimal sequence of jobs is obtained as follows. So the sequence is A, D, E, B, C. Okay. Now consider this sequence and consider the original table. So considering the first sequence of jobs, the minimum elapsed time can be computed as follows. You will consider only one sequence. No need to consider all the sequences which you obtain. So make the table like this: machine P, machine Q, machine R. Now we will go back to the original table. Write the job sequence which you obtain A, D, E, B, C. So in machine P, time in is 0, out time is 4. Machine Q, out in time is 4 because after 4 hours only it can go. Then machine Q, after 5, means 4 plus 5, 9 you will get. Then in machine R, it will go in 9 hours and come out after 17 hours. And similarly here, the idle time for machine R is 9 hours. Okay. So now you will keep on calculating like this. For job D, it will be 4, 10, 10, 13, 17 and 24. So just be careful while you all are writing. The same series applies over here. Just see the minimum, okay, and then write. 10, 15, 15, 19, 24, 35. For B it will be 15, 24, 24, 30, 35 and 45. For C it will be 24, 32, 32, 34, 45 and 51. Once this table is ready, now we can find the idle times for P, Q and R. So from the above table, minimum, optimum or total elapsed time is 51 hours. Idle time for machine P is T minus sum of processing time of 5 jobs on P. So you get 51 minus 32 is equal to 19 hours. And idle time for machine Q is T minus sum of processing time of 5 jobs on Q. So you get 51 minus 5 plus 6 plus 2 plus 3 plus 4, which is 51 minus 20, it is equal to 31 hours. And lastly, idle time for machine R is T minus sum of processing time of 5 jobs on R. So 51 minus 8 plus 10 plus 6 plus 7 plus 11, and you get 51 minus 42 equal to 9 hours. So students, today we have covered sequencing problem in detail. You can continue solving your exercise 7.2 and go through the miscellaneous problems once you have understood and you have practiced all the problems. All the best students. Thank you.